Let's go through an example of using Lakehouse Storage with a BYOC or bring your own cloud cluster. We'll go through the example to the point where we can actually see the data inside of an S3 bucket, and then we will query it using Athena. If you aren't familiar with BYOC, it's a StreamNative deployment option for deploying a Pulsar cluster into your cloud environment. When you manage your cluster through the StreamNative UI, as you can see here, it's going to look just like a fully hosted StreamNative cluster. However, in fact, the resources like your EKS cluster if you're using AWS, as well as the Pulsar resources deployed into that EKS cluster, are running in your cloud environment. Here I've logged into my AWS account, and you can see that there's an EKS cluster here. This is actually managed by StreamNative, and this is where the Pulsar cluster is deployed. But what I'm more interested in showing you today is how the offloading process works. As part of the permissions provided to StreamNative to manage your cloud environment, it's able to make S3 buckets. In this case, you can see this one ends in tiered storage SNC. Inside of that bucket is an object called myCluster followed by a cluster ID. If I go ahead and click on that, I'll see that I already have an object in there called myTenant. That's an existing tenant where I've already enabled Lakehouse Storage. Instead of just showing you that one working, let me show you how I can enable it for another tenant, and then we'll start testing it and query the data from it directly in AWS. Lakehouse Storage has already been enabled for my cluster. However, I have to enable it at the namespace level so that all topics inside of that namespace will start sending data to the Lakehouse Storage. I'm going to be using the pulsar-admin CLI tool. I've included directions in the description on how to download pulsar-admin, and then there's a series of the admin URL as well as the security credentials to get into my cluster to then start to make some changes. Using the namespaces command with the set-offload-threshold for my particular tenant and namespace. So I'm going to be enabling that by setting the size to 0. I've also included a link to the documentation on how to enable the Lakehouse Storage. You go ahead and hit enter on that, and it will go ahead and enable the Lakehouse Storage for this particular tenant and namespace. To test Lakehouse Storage, I'm going to start publishing message into a topic inside of that tenant and namespace where I just enabled the Lakehouse Storage. I'm going to be producing a message with the Avro schema, and just so we can keep track of the number of messages that I've published, and so that every message is a little different, so when I go look at it inside of S3 or actually in Athena, I'm going to be publishing 2 million messages where there's two fields. There's a user with the name John, and they also have an age, where that age is going to increment from 0 to 2 million. Now, the first time you use Lakehouse Storage with the current iteration, the offloading to Lakehouse Storage won't begin until the first rollover of a ledger. If you aren't familiar with the storage mechanism for Pulsar, it's how we divide data into chunks to store. So the first ledger rollover wouldn't happen until we've hit 50,000 messages and at least 10 minutes has passed. So I'm going to start publishing messages here, and then after around when 50,000 messages are published, let's go ahead and hop back into AWS, and we'll look at how the data starts showing up in S3, and we'll start querying it with Athena. We go ahead and publish these messages here. And that stipulation of the first ledger rollover will likely change in the future, but that's just the current iteration of how it's implemented. Here I've started publishing messages at a fairly slow rate. I don't want to batch messages because if you aren't familiar with how batching works, if you batch a bunch of messages into one essential batch, that batch on the server side is considered one message, and we would need to hit 50,000 of those. So I'm actually just going to publish individual messages here, and then once this value gets past 50,000, we'll head back on over to AWS. In the meantime, I've created a consumer, and I've consumed just one message over here on the right, and then that will create a backlog so that these messages don't get deleted, because they're still going to be subject to our regular message retention policies, which by default for Pulsar means that if you don't have a subscription in place and then a backlog start forming, those messages would end up being eligible for deletion. I could also have put a message retention policy in place as well to make sure they stick around. Here over on the left, I've gone over the 50,000 messages and at least 10 minutes have passed. So we should have had a ledger rollover by now. So these messages are now eligible for being offloaded into Lakehouse Storage. Looking here inside of my bucket for S3, after waiting the 50,000 messages and then about 2 minutes for the offloader to pick it up, I can see that I now have the new tenant showing up here as test tenant and my test namespace and my topic. If I go ahead and look inside of my partition, I can start to see my Parquet files and I'll sort them. So the most recent's here on the top. You can see that there's 2 files here. This was the last updated at 11:07. If I look, that was about a minute ago. I'm going to actually set up a table inside of Athena, and we're going to query the this S3 bucket, and I'm going to compare the data that's being written from my client to the most recent values that we're seeing inside of our S3 bucket here. So here I am in Amazon Athena, and I have a query here that selects all data from a table and orders it by publish time in descending order, which is then going to allow me to check what is the most recent age of the Avro object that we published, and I'll be able to compare that to the value that's in our producer so we can see how quickly the data can get from our producer into the tables in S3 or in the Lakehouse Storage. So here in the table, I'm going to create a new table from my S3 bucket, and I'll say test tenant. Actually, I'll say test topic here. And then I'm going to choose an existing database where to store the results or the schema. But in the S3, I'm going to browse into my tiered storage, into my new tenant that I just created and turned on the Lakehouse Storage for tenant. And then I'm going to select the input topic. If I click choose here, the data format is going to be in Delta Lake as an Apache Parquet file. I'll click create table. Under query 2, I'm going to go ahead and copy that, and I'm going to paste that in here, and it's going to be called mydatabase.testTopic, and then I'm going to order by the publish time in descending order. Go ahead and run that, and we'll take a look at the results. The most recent value is the age field at 51,938. Let's go ahead and take a look and compare that to what we see inside, or what we're publishing now with our producer. It looks like we're publishing at a value of around 55,800. Let me go ahead and do a comparison here as to how often this data unloads. And here we have an example where I've run the query again. I see results 60,761. The most recent I saw was 60,760. And if you can see over here on the left, I am publishing values at around 61,000. It doesn't necessarily need to close a ledger after the first one has been closed and the offloader has been initiated. Instead, it will offload data much more frequently.